everyone! Today we're going to explore some data cleaning techniques using R. We'll be focusing on practical aspects that you are likely to encounter in real-world data analysis scenarios. So let's dive right in and see what steps you need to take to make your data clean, accurate, and ready for analysis.
In the last video on data import, we learned about the read.csv function from base R. Today I will show you another function for easy data import, read_csv from the readr package, which is a part of the tidyverse. The tidyverse is a meta package for data science which offers a coherent and user-friendly data manipulation and analysis framework. We'll use it quite often from now on. Instead of loading individual packages, we can install the tidyverse like so, and it will load all the packages that are part of it. So read CSV with an underscore serves the same primary purpose of reading CSV files into R. However, there are some key differences, including how the functions handle data types, strings, and missing values. Also, the output of read CSV with an underscore is a tibble, which is a more user-friendly version of the data frame. So let's read in the data. This dataset offers some insights into product offerings, pricing strategies, and customer feedback from Costco's online marketplace. The dataset resides on Kaggle, and I will provide the link to it in the RMD file that comes with this tutorial. The dataset contains 1,757 observations and 8 variables, including subcategories, price, rating, and product description. Once the data is loaded, we can explore and inspect it. Functions like glimpse from dplyr package or summary from base R can provide a quick overview of the data structure, types of variables, and a peek at the first few rows of each column. We can see that all the variables in the dataset loaded as characters. This is a common thing when importing data, especially from formats like CSV. Let's focus on one primary conversion task based on our dataset, converting the price column to a numeric format. The price column is a character type because of the currency symbols and possibly some other non-numeric characters. To check for unique values that appear in the price column, let's use the unique function from base R. This will return a vector without duplicate elements. Now we can see that some values contain commas and other characters that need to be removed so that we can analyze the price values as numbers. We can remove these non-numeric characters using string manipulation functions from the stringr package, which is also part of the tidyverse. So let's see how this works. This %greater than% sign that you're seeing at the end of the first line of this code chunk is called the pipe. It's used to pass the output of one function directly as the input to the next function. In our case, the pipe takes my data table and passes it sequentially through a series of mutate transformations. Mutate is a function from the dplyr package, which is used for transforming or adding new columns to a data frame or a table. It takes an existing data frame, my data in our case, and modifies the price column. Each step in the mutate function is applied one after the other. Now let's look at each mutate transformation one by one. This line uses the strRemove function from the stringr package to remove the $sign from the price column. The $$ is a regular expression pattern where the $sign is escaped with a backslash because the $sign has a special meaning in regular expressions. This step cleans the price data by removing the currency symbol, making it easier to convert to a numeric format. This line removes any commas from the price column. Commas are often used as thousand separators in prices, but need to be removed to convert the data into numeric format. The strReplaceAll function replaces all occurrences of a comma with an empty string. The strTrim function is used to remove any leading or trailing white spaces from price values. This step ensures that no extra spaces are present at the beginning or the end of the price strings, which could cause issues in the numeric conversion. This is a conditional transformation. It uses strdetect to check if the price strings matches a numeric pattern, either an integer or a decimal number. This pattern is a regular expression that matches a sequence of digits, optionally followed by a decimal point and more digits. If price matches this pattern, as that numeric converts it to a numeric value. If not, it sets price to an A, indicating a non-numeric or invalid value. After these transformations, the price column in my data table is clean and converted to a numeric data type, with non-numeric or improperly formatted values replaced by an A.
I hope you found this tutorial useful. For more details and access to the dataset used in this tutorial, please refer to the accompanying RMD file where I've included the link to the dataset and some useful resources. Thanks for watching and happy coding with R.